Welcome everyone. This is 10.2 on systems of three equations. So we did systems of two equations, right? And you guys solve for x and y. And in this section, we increase the number of variables and equations. So there are three equations and there are three variables. Okay, so there's an x, a y, and a z. Okay, that we have to go ahead and solve. So your essential question for today is, how do I solve these systems? Okay, pretty basic essential questions. We're just going to learn that skill. So when we solve a system of equations, meaning two variables and two equations, we solved it through graphing, we solved it through elimination, and we solved it through substitution, right? In this lesson here, we're not going to graph, we're not going to substitute, we're just going to eliminate, okay? And there's a systematic way of eliminating. So that's what we're going to do today. All right. So for warm up, I want you guys to solve this system. Okay. X minus 2y minus z equals 1. Y plus 2z equals 5. And z equals 3. There are three variables, x, y, and z. And there are three equations. Right? So go ahead and try and solve this. I know that you guys can do it. So what we have here is we have z equals 3, right? So I'm going to go ahead and plug z equals 3 into here to solve for y. Okay? So y plus 2 times 3 equals 5. So that's y plus 6 equals 5. Subtract 6 on both sides. Y equals -1. Now that I have z equals 3 and y equals -1, I can use those two values to solve for x in my first equation, right? So I have x minus 2y minus z equals 1. So x minus 2 times -1 minus 3 equals 1. And then I go ahead and I simplify, do some basic algebra. X minus 1 equals 1. So then add 1 to both sides. X equals 2. Right? So I solve for x, I solve for y, I solve for z, I'm done. Okay? So in my solution, it's going to be fancy brackets. Okay? X, comma, y, comma, z. Okay? So just like here, instead of the parentheses, you're going to use fancy brackets. And that's my solution. Simple, right? Questions on this warm-up? No? So now our goal shifts from solving this, right? Now what we're going to learn today is how to get my system to look like this. Okay? Where one equation has all three variables, the second equation has two variables, and the last equation has one variable. Okay? Once we get this system, then we can just perform these steps, right, to find my solution. Okay? This system is called the triangular system because there's a triangle of zeros here. You guys can just remember that, right? There's 0x plus 0y, right? So that's the triangle system. Okay, so we want that triangle system. So our goal is to make that triangle system. Okay, In order for us to make this triangle system, the first step is to cancel out the x terms in two of the equations. And we're going to be using elimination for all of this. Okay? And then with the new equations that you create, the canceled x equations, you're going to try and cancel out the terms, cancel out the y term in one of the new equations. Okay? And by doing that, you guys should have that triangular system. Okay, so we're going to go over this example here. So my first step is to cancel out the x terms in the two equations. I'm just going to pick the bottom two as default. Okay, so I want to try and cancel out this guy first, this x. Okay, so if I subtract the first two equations together, right, x minus x, they will just cancel out, right? I would successfully cancel out that x. If I subtract the second equation. Okay? And honestly, when I do this type of math class, I don't like to subtract. I always like to add. So when you are subtracting, I am first going to distribute the signs out. Okay? So I'm going to rewrite the first equation equals 1. And then the second equation, I'm just going to go distribute that out. Negative x minus 2y plus z equals negative 13. This negative goes to 4 things, okay? Including that 13 as well. Okay, so it turned into negative 13. All right? So then once you do that, now I can add the two up together. So x plus negative x, they cancel out. Negative 2 minus negative 2y minus 2y, that's negative 4y. 3z plus z, that's plus 4z, equals 1 minus 13, that's negative 12. Okay, and notice that my new second equation does not have an x value, right? That's what we want. Okay, we want to cancel out that x. So my first objective, I completed. Yeah. So my new system, if you guys wanted to write out each and every little step, would be, this would be my first equation, this would be my second equation, and this would be my third equation. Okay, that would be your new system in terms of this. Okay, now I want to cancel out this 3x. Okay, I want to cancel out the 3x's, the 3x, both x's, right? That's the first step here. So I can essentially multiply the first equation by negative 3 and add it to my third equation, right? There essentially would be negative 3x and positive 3x, so they would cancel out. I'm going to do this math first. I'm going to distribute out the 3, the negative 3. So that's negative 3x plus 6y minus 9z equals negative 3, right? And then I have my third equation, 3x plus 2y minus 5z equals 3. So then when you add those two together, you would end up getting 3x, or negative 3x and 3x, they cancel out. 6 plus 2 is 8y negative 9z minus 5z, that's minus 14z, equals negative 3 plus 3, that's 0. Right? So now I don't even have an x value here. So my first step, where I needed to cancel out the x terms in two of the equations, I did. This is my new third equation. Okay? That makes sense? Now, going to my second step, cancel out the y term in one of the new equations. Using these two equations, I want to cancel out the y. So negative 4y and 8y, okay? So I can multiply the second equation by 2. And then add it to this one, right? Because if I multiply this by 2, I would get negative 8y plus 8y equals negative 24, right? And if I add the third equation, 8y minus 14z equals 0. And if I go ahead and I add it together, these 8y's cancel out, right? Negative 8y plus 8y. And then positive 8y minus 14z, or no, that's not y, I'm sorry. That should be a z, right? 8z minus 14z, that's negative 6z, equals negative 24 or plus 0, that's negative 24. Now I can go ahead and solve this for z, right? So this is my new third equation. Okay? So my system, if you wanted to, my first equation would be x minus 2y plus 3z equals 1. My second equation would be negative 4y plus 4z equals negative 12. And my last equation would be negative 6z equals negative 24. That would be my system, right? And I wrote it kind of funky here, but you guys see that there's a triangle here, right? There's no x here, and there's no x and y here. So now I can solve it. This is a one-run problem, right? So we can go ahead and solve it. So if negative 6z equals negative 24, z is going to equal positive 4, right? You guys just do the math in your head. So now with that, positive 4, I'm going to plug it into here. So that's negative 4y plus 4 times 4 equals negative 12. So that's negative 4y plus 16 equals negative 12. Subtract 16 on both sides. I am going to get negative 4y equals negative 28. Divide by negative 4, divide by negative 4. Y then equals positive 7. Right? So now with y and z, I'm going to plug it into my first equation to solve for x. All right, and I'm running out of room, but I'm going to put it right here. Okay? So that's x minus 2 times my y value is 7 plus 3 times my z value is 4 equals 1. So that's x minus 14 plus 12 equals 1. X minus 2 equals 1. Add 2 to both sides. X would equal 3. Right? So I have an x value of 3. I have a y value of 7. I have a z value of 4. That is my solution. Cool? Okay. So we are good with that. My next example is this. Okay. And lucky me, I do not have an x here. So they did half a step for us. Right? So I'm going to subtract the first equation by the last equation. So that's x minus y minus z equals 4 minus negative x plus y minus 2z equals 5. Right? But instead of minusing, I'm just gonna switch the signs. Okay, so I'm gonna make that a positive, this a positive, this positive a negative, this negative a positive, and that positive a negative. So if I rewrite this whole thing, x minus y minus z equals 4, it's gonna be plus. Oh no, what did I do wrong? If I plus x, I get 2x, right? I should have just added the 2. Because it's already a negative, right? If I add x minus x, they would just cancel out, correct? Yeah. So here, I'm going to add the 2, x minus y minus z equals 4. And I have minus x, negative x plus y minus 2z equals 5. And I'm going to go ahead and add it. So x minus x, they cancel out. Negative y plus y, they also cancel out. Okay? So we have negative z minus 2z, that's negative 3z, equals 4 plus 5, that's 9. Divide by negative 3, divide by negative 3, z then would equal negative 3. I already have my z value, right? So with that z value, I can plug that guy back into this equation to solve for y. So 2y plus negative 3 equals negative 1. That's 2y minus 3 equals negative 1. Add 3 to both sides. 2y would equal 2. Y would equal 1. With y and z in hand, I can plug it into the first equation to solve for x. Okay? So that's x minus 1 minus negative 3, which is plus 3, equals 4. So x plus 2 equals 4. Subtract 2, subtract 2. X would equal 2. So my x value is 2, my y value is 1, and my z value is negative 3. Okay. Questions on that? Fairly simple, right? So that's when you have a solution. Okay. Let's try this one. all of my x's are different. So in order for me to get rid of this x value, the negative 3x, I am going to multiply the top equation by 3, and then multiply the second equation by 5. Right? So that way I can have positive 15x and negative 15x, and the x's would cancel out. So if I do that math, if I distribute out the 3, I would get 15x plus 27y minus 9z equals 9. And I have negative 15x minus 45y plus 20z equals 10. Now, if I add the two together, these two guys cancel out. What's 27 minus 45? 18. Y negative plus 11z equals 19. Right? Okay. So that's my new equation 2. Trying to get rid of this 4x here. I'm going to multiply the top one by 4 and multiply the bottom one by negative 5. Okay? So 5x plus 9y minus 3z equals 3. And then the bottom one is 4x plus 9y minus 5z equals negative 7. Okay, doing this math, distributing out the 4, I get 20x plus 36y minus 12z equals 12. Distributing out the negative 5, negative 20x minus 45y plus 25z equals negative 35. Add the two together. Those two guys cancel out. Negative or positive 36 minus 45. That's 9y, negative 9y plus 13z equals negative 23. Right? Okay. Now to get rid of the y's here, I want to multiply this one by negative 2. If I multiply this one by negative 2, then I have positive 18y, and I have a negative 18y here, right? Okay. So that's positive 18y minus 26z equals positive 46. And if I add negative 18y plus 11z equals 19, add them up, those two guys cancel. That's negative 15z equals 46 plus 19. That's a 5, 1, 4, 65. Okay. And if I divide this by negative 15, divide this by negative 15, z is going to equal negative 13 thirds, right? Okay, and sometimes you're going to get a variable like this or a fraction like this. So then this, you can plug this back into here to solve for y, and then plug this back into here to solve for x. Okay, I'm not going to show you that step. All right. Okay, we're done with regular ones. These are the special ones. All right. You're going to be given something like this. You don't know that it's special yet, so we're going to go through the steps. Okay, I'm going to add the first row and the last row. So if I do that, I get negative x plus 7y plus z equals 3. And then add this. Yeah, add it up together to get rid of the x. 7 minus 6, that's y. Z minus 2z, that's negative z, equals 3 minus 5, that's negative 2. Right? And if I subtract, if I multiply this by a negative 1, then I'll have a positive x and a negative x here, right? So that's what I'm going to do. So negative x plus 7y plus z equals 3. And I have minus, I'll just show you the steps here, plus y plus 5z equals 9. Right? But instead of subtracting, I am going to add it. So I'm going to rewrite the first row or first equation. Okay? And then distribute out the negative. So that's x minus y minus 5z equals negative 9. And then I'm going to add it together to get those two guys cancel out. 6y minus 4z equals negative 6. Okay? So I'm going to get rid of the y's. So 6y minus 4z equals negative 6. Multiply this one here. Y minus z equals negative 2 by negative 6 to get 6y minus 4z equals negative 6. And then negative 6y plus 6z equals positive 12. Okay? So then those two guys cancel out, and you're left with 2z equals 6. And then you can solve for z, plug that back into here, and then get y, and then plug that back into here to get x. Right? Okay? I have two more highlighting special steps or special solution. So this one here, it's a no solution. I'll show you why. Okay? So here we're going to go through the steps again. I'm going to 3 times row or equation 1 minus equation 3. Okay? Doing so, it cancels out that one. Right? How do I cancel out this one here? That's going to be, I'm going to do this simultaneously. That's going to be 2 times the first equation minus the second equation. Okay? So kind of doing this simultaneously, this would be 3x plus 6y minus 6z equals 3 minus 3x minus 4y plus 3z equals negative 5. Adding the two together, those two guys cancel out. 6y plus 4y, or 6y minus 4y, that's 2y. Negative 6z plus 3z, that's negative 3z, equals negative 2. Doing this math here, distributing out the 2, 2x plus 4y minus 4z equals 2. And then negative 2x minus 2y plus z equals negative 6, right? Just switching up the signs. We're going to add it together. Those two guys cancel out. That's 2y minus 3z equals negative 4. Right? So then I try to go ahead and I subtract the 2, right? 2y minus 2y, they're going to cancel out. So if I subtract, I'm just going to use this one here. 2y minus 3z equals negative 4. Can you guys already see it? 2y minus 2y, that's a 0, right? They would cancel out. Or you know what? I skipped a step. So 2y minus 3z equals negative 2. Negative 2y plus 3z, distributing out the negative here, equals positive 4, right? So 2y minus 2y, they would cancel out. Negative 3z plus 3z, they would cancel out. So I'm left with a 0 here, right? Equals negative 2 plus 4, that is 2. What? Yeah, 0 equals 2. That's what I got, right? Is that true or false? If it's false, if you end up with a false statement, your answer is no solution. Okay? All right? Okay. My last one of the day, I know we did a lot, is infinitely many solutions. Okay? What do you think we'll end up with? Infinite amount of solutions. Thank you, Captain. What do you think we'll end up with? 0 equals 0, or a true statement, right? And once that happens, I'll show you what to do with it. Okay, but we're going to act like we don't know, and we're going to go through the steps, right? So this one here, I can literally get the subtract the bottom two, right? So that would be 2x plus y plus 4z equals 2. And this would be negative 2x minus 4y plus 2z equals negative 8. I already distributed out the negative in my head. Okay, so we're going to add these two guys together to get rid of that. Y minus 4y, that's negative 3y, plus 6z equals negative 6. I'm going to get the second equation. I'm going to multiply negative 2 to the first equation. Okay? So when I do that, I have 2x plus y plus 4z equals 2. And I have negative 2x plus 2y minus 10z equals 4. So if I add those guys up, I'm left with 3y minus 6z equals 6, right? So here and here, I'm going to add these guys together. So I'm just going to write down the second equation here, right? And then add it. If I add it, all of these guys become 0, right? Negative 3y plus 3y, that's a 0. 6z minus 6z, that's a 0. So I have a big fat 0 here. Negative 6 minus 6, or negative 6 plus 6, that's a 0, right? That's a true statement. 0 equals 0, true statement. This is what we do, okay? Ready? I am gonna, if you end up with a true statement, right? It's infinitely many solutions, yes, but we have to solve for x and y in terms of z, okay? So first things first, z equals z, right? So my solution, z is just z. Okay, that's the springboard. Okay, if z is just z, I'm gonna get this equation and solve for y. Okay, in terms of z. So I'm gonna add 6z, add 6z, 3y equals 6z plus 6. Divide by 3, divide by 3, divide by 3. Y is equal to 2z plus 2, right? So that's my y, 2z plus 2, okay? I'm going to get y equals 2z plus 2 and z equals z and plug it in to that first equation to solve for x. So x equals negative y, so negative 2z plus 2 plus 5z equals negative 2. And then just solve for x, or x minus, huh? That's nothing. That's a mistake. So I have x minus 2z distributing out this negative minus 2 plus 5z equals negative 2. So I have x plus 3z minus 2 equals negative 2. I'm just going to subtract 3z and then add 2 to both sides. When I do that, I'm going to have left with x equals negative 3z, right? So 3z or negative 3z is my solution. So if you have infinitely many solutions, just leave it in terms of z, okay? Because having infinitely many solutions doesn't mean I can put in any number for x, any number for y, any number for z, right? I can't just say, oh yeah, x is 5, y is 10, and z is 1,000,000. I can't do that. Yeah, there's infinitely many solutions, yes, but there must be a system or some rules behind how those solutions work. And the rule is this. That relationship is this. Does that make sense? Yeah. So you can plug in any number for z, but y must be this number then, and then x must be this number. Okay? That is your lesson for today. Next time we meet, we are gonna go into matrices and solve this via matrices. And I promise it's the same type of math, but it's more organized than this. Okay? So see you on the next one.